Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. In this video, we'll solve exponential function graph problem. As per the problem, match each exponential function with its graph. We are given four exponential function equations and we are given four graphs. We have to match each of the given function equations with its graph. Let's start by analyzing the given function equation in part A. F at x equals 4 to the power x. As you can see, this is an exponential function because the input variable x is in the exponent on 4. 4 is the base of this exponential function. This function f at x represents parent function or base function for exponential function with base 4 because in this function equation there are no constants that result in any kind of transformations. The general equation of a transformed exponential function with base 4 is y equals a times 4 to the power k times x minus d plus c. Different teachers use different letters for A, K, D, and C, but the resulting transformations are the same. If we compare this general equation with the given function equation f at x, we can see that A is equal to 1, K is equal to 1, D is equal to 0, and C is equal to 0. That's why the given function f at x represents the base or the parent function. As you may know, f at x equals 4 to the power x represents an increasing function because the base is 4, which is greater than 1. That means as we go from left to right along the graph of this function, the y values or the function values increase. As you may know, an exponential function has a horizontal asymptote. The horizontal asymptote of this function is at y equals 0 because the c value is equal to 0. So as per this analysis, the graph for function f at x should be graph number 4. Because as you can see in this graph, the function is increasing. As we go from left to right, the y values or the function values increase, and this graph has a horizontal asymptote at y equals 0 or the x-axis. Now we can analyze the second given function g at x equals 4 to the power negative x. The difference between function g at x and f at x is that there is a negative sign with x. This function g at x has the same base 4. If we compare the general transformed equation with the function equation for g at x, we can see that a is equal to 1, k is equal to negative 1, d is equal to 0, and c is equal to 0. K is equal to negative 1 because of the negative sign with x. As you may know, if k is equal to negative 1, there is reflection over y-axis. So the graph for function g at x is the graph of function f at x that is reflected over y-axis. We can see that if we reflect graph number 4 over the y-axis, we get graph number 1. So the graph for function g at x is graph number 1. Now we can analyze the function in part C, h at x equals minus 4 to the power negative x. This function has base 4. If we compare this function equation with the general transformed equation, we can see that a is equal to negative 1, k is equal to negative 1, B is equal to 0, and C is equal to 0. So we can see that the difference between the equation in part C and the equation in part B is that the A value has changed from 1 to -1. As you may know, if A is equal to -1, there is reflection over x-axis. That means if we reflect the graph for part B over the x-axis, we should get the graph for part C. The graph for part B, G at x, is graph 1. If we reflect graph 1 over the x-axis, we can see we get graph 2. So that means the graph for function in part C is graph 2. Now we can analyze the function in part D. R at x equals -4 to the power -x plus 3. In this function, the base is 4. If we compare the general transformed equation with this function equation, we can see that A is equal to -1, K is equal to -1, B is equal to 0, and C is equal to 3. The difference between the function in part C h at x and function in part D is the C value. It has changed from 0 to 3. As you may know, C results in vertical translation. The transformation due to C equals 3 is vertical translation 3 units up. So we can obtain the graph for part D function R at x by vertically translating the graph for function h at x in part C 3 units up. So if we look at graph 2, which is the graph for part C, and if we translate it 3 units up, we get graph number 3. That means the graph for function R at x in part D is graph number 3. So these are the graphs for the given exponential functions. So these are the steps you have to keep in mind to solve this problem. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.